Hello biochemistry students. In this video we're going to take a look at naming and classification of enzymes. Now naming enzymes goes like this.
I always wanted my own little bunny rabbit. I will name him George, and I will hug him and pet him and squeeze him.
I'm not a bunny rabbit.
And pat him and pet him and...
You're hurting me. Put me down, please.
And rub him and caress him and...
I ain't no bunny rabbit!
No, that's not how we name enzymes. Naming enzymes, we start out with, there's three basic ways that we could do this. The first way is taking a look at the suffix. So naming enzymes, the first way, I'm going to say suffix. And the suffix usually ends in ase. And those of you that have taken a biology class will recognize this. The ASE ending tells us that this is an enzyme. And so some examples of this here might be urase, or sucrase, and they all end in ASE. Now, of course, having said that, there's some exceptions to the rule. So enzymes such as trypsin and pepsin, these end in the IN ending. And why is that? And that goes back to the fact that people started naming enzymes and the name stuck before they got together and came up with the rules. And I don't know if I mentioned to you that chemists are lazy, but the names just kind of stuck and nobody bothered to rename the darn things. So that's why usually it ends in ACE, but sometimes we have IN in these two digestive enzymes. Now, another way that we name enzymes is based off of the type of reactions they catalyze. And so examples of this might be oxidase, or hydrolase. And these two names would be prefixes, so that these would go in front of the name of the enzyme. And so like an oxidase would be oxidizing something, and a hydrolase would be catalyzing the hydrolysis reaction. So I'm just going to say here, oxidase catalyzes an oxidation reaction, and here a hydrolase is going to catalyze a hydrolysis reaction. And then the last way that we might name these things would be identifying the substrate. So 3. Identity of the substrate that has been catalyzed. Now substrate is a new word here. We've not introduced this one yet, and substrate is just a fancy word for a reactant. So a reactant is something that the enzyme will act upon. So it's the thing that is going to be catalyzed. And so a couple examples of this might be glucose oxidase. And so glucose would be the substrate. This is the thing that's going to be oxidized, all right? So glucose oxidase is an enzyme that oxidizes glucose. So it's really nice how the name helps tell us what's happening here. Another example, this might be succinate. Succinate dehydrogenase. Succinate dehydrogenase. This is an enzyme that is going to remove hydrogen from succinate. Enzymes can be classified into 6 categories, and the first category we're going to take a look at is oxidoreductases. Now, oxidoreductases, these catalyze oxidation reduction reactions. And oxidation reduction reactions are always linked to something. Something's being oxidized, something is being reduced. And an oxidoreductase enzyme is going to require a coenzyme. So something is going to have to be oxidized, something is going to have to be reduced. Now it's a little bit of a head scratcher here, but I'm going to draw out an oxidoreductase reaction here and just try to explain all of this. So we're going to start out with lactate. So here is a lactate molecule that has been reduced. And that's because we've removed a hydrogen atom here and the charge goes down, so it's been reduced. And we're going to react this here with NAD+. And if you've taken chemistry, you might recognize NAD+ is something to do with metabolism and energy production. And we'll spend more time taking a look at this in the next module. Now, this right here is a coenzyme that's going to be oxidized. So I'm just going to say oxidized, and this is a coenzyme. And so what's going to happen here? Well, we're going to have a chemical reaction that will be catalyzed by an enzyme. In this case, the enzyme is going to be lactate dehydrogenase. That's a mouthful. So let me see if I can't write this out here. Lactate dehydrogenase. Dehydrogenase. Okay, so just looking at the name here, it's an enzyme that's going to act on lactate and it's going to remove hydrogen. So the name kind of tells us what's going to happen. So over on the other side here, let me draw this molecule here where I remove some hydrogen. And the hydrogen we're going to end up removing is this one here and this one here. And so the new structure on the product side here So on the product side here, if we remove this hydrogen and this hydrogen here, we'll be left with just the oxygen. And then this bond will come around over to this side and create a double bond with the oxygen over there. So now carbon has 4 covalent bonds there. Now this new molecule is called pyruvate. And then what happens with the NAD here? Well, the NAD is going to pick up one of those hydrogen atoms. And we'll be left with an additional hydrogen atom over here. And over here on this side here, we're going to have our reduced coenzyme. Now, you might be thinking to yourself, oh my gosh, there's a lot of stuff going on here. Do I need to memorize this? And no, you don't need to memorize these names, like pyruvate here and such. What I want you to be able to recognize is if the enzyme is dehydrogenase, then recognize that it's removing hydrogen. And this classification, this oxidoreductase here, in this case here, we're oxidizing and reducing a chemical reaction. So if we see something that's changing the charges like this, we should recognize that this is an oxidoreductase reaction. So you don't have to memorize the reactions and the products and the substrates and such here. I just need you to be able to recognize what type of reaction this is. The next category or classification of enzyme is transferases. Now, transferases, as the name implies, is going to be catalyzing the transfer of something from one molecule to another. So a transferase is an enzyme that catalyzes transfer of a functional group from one molecule to another. And so I'm going to draw out a chemical reaction here involving a transferase. And again, you don't have to memorize the names or this chemical reaction. I just want you to be able to recognize when a functional group is moved from one molecule to another that is involved or catalyzed by a transferase. So an example of this would be glucose here. So here is a glucose molecule like this. Okay, CH3 and glucose. Now, I didn't put in all the hydroxyl groups on this because I'm lazy, all right? But this is just kind of an outline of a glucose molecule. And we're going to react this here with ATP. And remember, ATP is adenosine triphosphate. So there's 3 of these phosphates here. Okay, adenosine triphosphate. And then this reaction is going to be catalyzed by something called hexokinase. Hexokinase. And the name, you don't need to memorize the name here, okay? But it is a transferase. So what's going to happen here is we're going to take one of these phosphate groups and we're going to move it from ATP and we're going to attach it here onto the glucose molecule. So when we remove one of these phosphate groups, instead of being adenosine triphosphate, it becomes adenosine diphosphate. Adenosine diphosphate. And then our phosphate group is going to be attached onto the glucose. So attached onto the glucose, I'm just going to put a phosphate group like this. I'm just being lazy drawing it like that. So we've taken one of these phosphates off of ATP and we've just transferred it onto glucose over here. And so that is a transferase reaction. Hydrolases are enzymes that catalyze the hydrolysis reaction. So hydrolysis is when we use water to break a molecule into two pieces. And we've seen this reaction before. We may not have looked at the enzymes involved in this. So an example of a hydrolase reaction would be something that would take a carbohydrate and break it into two monomers here. So I'm going to take a disaccharide of maltose. So here's maltose. Maltose is a disaccharide, and we're going to add water to this. Add water, and we're going to use an enzyme. In this case, it's going to be maltase. And maltase is the thing that dreams are made of. Or not, that's kind of an obscure cultural reference. So this maltase, look at the name here. It's an ACE, it's an enzyme, malt, okay, it's going to break down maltose, okay, into two monomers. And so the two monomers here are going to be two glucose molecules. So I've run out of board here, so I'm just going to make a couple of glucose monomers like this. Okay, there's one, and here is another one over here. And because we've broken this apart like this, we're going to end up then with like an OH like this and an OH like that, okay? All right, so there's a hydrolase, using water to break apart a disaccharide or a polysaccharide into smaller pieces. Now, lyases are enzymes that catalyze the addition of a group to a double bond or the removal of a group to form a double bond in a manner that does not involve hydrolysis or oxidation. Okay, so what's going to happen here? We're either going to create a double bond or we're going to break a double bond. And we're not going to change the charge of the molecule, and we're not going to break the molecule into smaller pieces. So an example of this is going to be fumarase. So I'm going to draw the fumarate molecule first. So here's fumarate, and you can see there's carboxylic acids on either end here. They have a charge, and then there's that double bond. All right, so because this is a lyase, we're going to do something with that double bond. And we're going to add water. And our enzyme here is fumarase. So this is an enzyme that catalyzes fumarate. And we're going to, as you can imagine here, we're going to take water and we're going to use it to break this double bond. So this water molecule here, we will break it apart, and we're going to then use that to break apart the double bond, and we'll end up with OH and hydrogen here. And now this here, this product is the product of the lyase reaction. But notice we didn't change the charge here, and so the charge still stays the same, okay? So it's not an oxidoreductase reaction here. And we didn't break it into smaller pieces, okay? So we didn't break it into the smaller pieces, and we didn't transfer a functional group, really, from one thing to another. So it's not a transferase, it's not an oxidoreductase. This here is a lyase reaction. An isomerase is a classification of enzyme that causes the substrate to rearrange itself. So it takes the atoms in the substrate and rearranges them into a new conformation. So an example of this would be like this. So this molecule right here is called 3-phosphoglycerate. 3-phosphoglycerate, phosphoglycerate. And really what's going on here is we've got a carboxylic acid here that has lost its hydrogen, and we have a phosphate group attached. And we're going to take this molecule and we're going to rearrange it. So we're going to use an enzyme here. And this enzyme here is named after the substrate. And so this is phosphoglyceromutase is the enzyme. Phosphoglyceromutase. And mutase, I mean, just kind of the name gives you the impression it's changing things somehow. And so what will end up happening is we're going to take these atoms and we're going to mutate them. We're going to rearrange them into a new isomer. And so this looks very similar. This product over here looks very similar to this, except we're going to take this phosphate group and replace this hydrogen here. So we're just going to flip-flop these two. So we'll put the phosphate group here. Hydrogen comes down here. And the name of this changes. This becomes 2-phosphoglycerate. Phosphoglycerate. And don't worry about the names, don't worry about the structures here. That's not important. The important thing is can you see that these are both made of the same atoms and they've just been rearranged? And if they've just been rearranged like that, then this is the product or the result of an isomerase. And you see the phosphate group on here and you go, oh, wait a minute, maybe that's a transferase here. Well, a transferase is where we take it from one molecule and move it to another. Okay, so this is not moving things from one molecule to another. This is just taking one molecule and rearranging things. That's an isomerase. And the last category we're going to take a look at is a ligase. And a ligase takes two different molecules and joins them together, but uses ATP, uses adenosine triphosphate. So that's a ligase. And an example of this is if we were to take, say, carbon dioxide, and we're going to combine it here with pyruvate. Pyruvate and ATP. And the enzyme that is going to cause this reaction to happen, the ligase enzyme, is going to be pyruvate carboxylase. And the name itself kind of gives us a clue as to what's happening. it's going to take pyruvate as its substrate here, and then it's going to carboxylase. Carboxylase is our carbon dioxide. So we're going to add carbon dioxide to this molecule. So then our product over here is going to look like this. This product here has a name, and it's oxaloacetate. And now we've used the energy from ATP, and so this becomes, instead of adenosine triphosphate, becomes adenosine diphosphate, ADP, plus a phosphate group, plus a hydrogen ion. So the names and the structures here are not important. I don't need you to memorize those. But what I do need you to recognize is that a ligase uses ATP to combine two molecules together. And we've seen ATP before. We've seen it in transferases, for example, but that's moving something from one molecule to another, okay? And so that's different. This is combining two molecules together. That's a ligase. All right, so that's it for our categories of enzymes.
Harry, what is it?
The stuff that dreams are made of.
Huh?